So, welcome to the overview of Linaro DRM. This session's actually been made from half an hour to an hour, so if anybody's expecting it to be 25 minutes, then just a little pre-warning for you. This is briefly what we're going to cover. A bit of an introduction to what Linaro offer for digital rights management. A look at the CDMs that we're developing, and two main focuses: what we're doing in Linux with OpenCDM, what's new, what we consider left to do, and then the same for Android. So a brief look at the architecture, what CDMs we're developing, what's new, what we think is left to do, and at the end, a kind of brief update on secure data path. But there's other presentations from Cyril and Ken on a bit more detail on exactly what's happening there. So a brief terminology check. EME stands for Encrypted Media Extensions. DRM, Digital Rights Management, not to be confused with Direct Rendering Manager. So if you see it in this presentation, it's usually Digital Rights Management. CDM, Content Decryption Module. CENC, Common Encryption, so allow us to encrypt a stream and decrypt it with different key systems. And then Widevine, which is Google's key system. Playready, which is Microsoft's key system. And ClearKey, which is a key system defined by the EME spec, which just uses an unencrypted key but allows us to have the same kind of data flow. So Linaro DRM. In LHG, we've been providing some reference DRM integrations with Opti for Playready, Widevine and ClearKey. And they're based on various open source components for Linux and AOSP. So typically these components include ARM-trusted firmware, always Opti, U-boot or EDK2 bootloaders, Linux kernel, and then on the Android side, AOSP and ExoPlayer, and on the Linux side we've been using Chromium web browser and WPE. On Linux, we're mainly focusing on EME integration with Chromium browser and WPE, and we've been doing this using a piece of software called OpenCDM that I'll talk about later. And currently we support the Playready and ClearKey CDMs. And on AOSP, we use the quite well-defined framework in AOSP for media DRM and media crypto, and we're supporting Widevine, Playready and ClearKey in AOSP, mainly currently using ExoPlayer as our kind of test media playback application. So I have a brief look at EME. It's a proposed recommendation from W3C to extend HTML media element to enable web applications to interact with encrypted content. And most browsers support it. This is taken from the EME spec, and it gives you a bit of an overview of what's going on. You see that hopefully. So this is the web application. And these are the APIs talking to the browser, and that's mainly what this spec defines. And the EME app goes off to the license server, gets a key, and then talks to the browser. Down here we have the CDM, which is the bit of software that's going to make the magic happen for the browser. But that's the API. This isn't really defined by the spec, and that's kind of up to the browser to implement. So in LHG, we've been using the -JS EME app, which is an open source project. Linaro have signed a contribution license with them, so we can commit patches to them. Mainly using this to test Playready playback. And we're also been using another EME app that's including the Chromium source tree, and that's very simple sort of HTML implementation to test the ClearKey. So CDMs, like I said earlier, it's the bit of software that is giving your target the functionality to decrypt the encrypted stream. It's typically a commercial key system like Widevine or Playready, but it can be a ClearKey, which can be fully open source. And why are we doing this? Well, in Linaro, we're mainly working on ARM SoCs, so we have limited CPU power. We want to achieve zero copy, make use of any SoC acceleration for the decryption, and also to achieve the highest levels of certification for Widevine, like level 1 or SL3000 on Playready. We need to protect the decrypted content using some form of memory firewall, so maybe the trust zone address space controller or RDC, or some form of hardware firewall. So the Linaro reference solutions with Opti, we're attempting to address those three features really with what we're doing. So we're going to talk about first on Linux, brief look at the architecture, what we're doing, what's new, what's left to do, and then we'll move on to Android. So like I said, the main piece of software we're using is something called OpenCDM, and it's based around a specification written by Microsoft called Content Decryption Module Interface Specification. And Microsoft developed this as a way for open source browsers to support DRM without actually having to license the DRM scheme. And they did this reference solution with Fraunhofer Focus, which is an implementation of this specification. But it's no longer really maintained by Fraunhofer Focus, so it led to several forks, one in Linaro to address some of the shortcomings that Linaro saw with it, and to do the Opti integration with it, and also Metrological that worked with the WP browser. They created a fork so that support for their browser. Linaro's involvement has mainly been through supporting ARM, keeping the integrations with Chromium and Opti up to date, and recently there's a presentation later by Shiva adding the WPE browser support into the plugin. So this is what the stack looks like. You've got the browser at the top, and OpenCDM is running as a plugin to the browser, and then that talks over RPC, this CDMI interface, to a separate service that's called CDMI service, and into that has compiled the support for the particular key system that you're looking at. So we had a ClearKey just using OpenSSL library, and we have a ClearKey that uses Opti, so the AES decryption is done in the T side, and then we also have a Playready TA which implements the Playready key system. And there's some links there to the various repositories. So everything apart from the Playready stuff is open source, so you can go download one of our builds. For HKG, you get the Chromium OpenCDM and also the ClearKey TA and the full pipeline. So brief look at OpenCDM plugin. It's split into 3 layers: a browser glue layer, core layer, and a comms layer. Browser Glue used to only support Chromium, but recently been doing work to add WPE into that layer. The core layer is the core, and the communication layer, currently it's using RPC, but it's abstracted in a way that you could put some other IPC mechanism in there, which is something we're considering doing. And then on the CDMI service side, it's really that upside down, so it's RPC coming in, converting to the CDMI, and then CDMI is converting into the actual DRM key system that you're implementing. So currently this is a compile time decision. So you make, by default, it will do the ClearKey because that's all open source, doesn't have any licensing restrictions. But if you're a Linaro member and you've got the appropriate license agreements with Microsoft, we can also enable Playready, which will be compiled in, and then what we don't show on that stack then is the communication off to the trusted world, and then it will do the decryption in the T. I won't get into this in much detail, but we integrate with Open Embedded. There's various recipes. Everything we can have open sources on our GitHub page, but then for the Playready parts, that's access restricted. It's mainly BB appends to the public recipes, just to add in support for the proprietary components. Like I said, you can do a Opti ClearKey build for high key. The instructions are at the top to clone the code, build it, and run it. There's also a blog post there which has some instructions on how to recreate this. For debugging, there's enable debug, compile time switch for the CDMI service. That's quite easy to debug. You can just use GDB on the target. For Chromium, a debug build of Chromium ends up creating a massive, massive binary. So we've added an option where you can just create a debug build of the plugin, and that gives you very quick build time, your usual Chromium binary, but you get symbols in the actual Chromium plugin. And there's quite a neat extra command line option you can pass to Chromium. So when it loads the plugin, it will load it with GDB server, and then that allows you to debug the plugin. Because you've only built the plugin with debug symbols, you only unwind the stack up to where it enters the plugin, but that's usually enough to debug the problem you're facing. So what's new since we last spoke? Andre, sat over there, did work updating from the old Chromium release. We were using version 43 to Chromium 53. That was done a little while ago now, and we're in the process of rebasing from Chromium 53 to Chromium 65, which is the latest release. But that work is, Chromium 65 is running, but we don't have the OpenCDM parts yet. Possibly by Friday, maybe by Friday. We've also been integrating the WPE browser support, so we have the one plugin that supports both browsers. We have various CI loops we've been setting up, so one on the Playready side is now integrated with Gerrit, so you push a patch to Gerrit for the Playready, it does a build test. And we've migrated over to having common Android and Linux branches. So it's the same trusted application branch that's built in both environments. In progress, we have more to do on the CI. We want to get OpenCDM, GitHub, integrated with Jenkins, so we have some outstanding CTT tickets for that. As we add in new browsers, we have more and more testing we need to do. So we're trying to reach a stage where, you know, GitHub pull request will do a build for WPE, it will do a build for Chromium. Hopefully it goes off and uses Lava to do some runtime tests. We don't quite have all the ducks in a row yet for that, but it's getting there. We're also looking at WPE reference builds like we do with Chromium and ClearKey at the moment. And we're looking at automated Playready Lava test. What's left to do? So the first bullet point, we've been working on secure data path, mainly on Android currently, and we need to move that work across to Linux. That's actually probably quite a lot of work to get that going. You may have noticed in Android we have the Widevine CDM, but we don't have that in Linux at the moment, so another work item is to get Linux Widevine Opti support. I mentioned CDMI service is currently compile time option for the key system you're supporting. We'd like to have a multi-DRM in there, so it can be compiled with several key systems and choose which one depending on what the browser requests. These are kind of in priority order in some ways. The latest version of the porting kit, version 4, has actually changed the CDMI layer that we integrate with. So there's an outstanding work item to redo that integration if we want to move to the latest porting kit. And we're endeavouring to become the upstream repository for OpenCDM. So with the work Shiva and Morty have done to unify WPE and Chromium forks, we don't want them to re-diverge again. Now we've put this effort into unifying them. And like I said already, the CI testing and Lava testing, there's definitely more we can do there. So AOSP, with AOSP we've been focused on ClearKey, Widevine and Playready. The DRM architecture in AOSP is a lot more defined, so we use the DRM and media crypto frameworks. Where possible, we try and build on the LMG and SWG work, so we try and use a board that LMG are supporting, like the X15 or the High keyboard, so one that they provide releases for, but also has Opti support is the main requirement. And the recent focus has been on adding ClearKey and secure data path support. So this is a diagram taken from the page up there. Shows you the Java application here, the APIs it's calling to some Java classes here, and then eventually it works on a plugin-based architecture. Depending on the UUID, it searches for a plugin. And for each key system or DRM scheme that we're supporting, we need a media DRM and media crypto plugin. So that needs to be implemented for each DRM scheme. So I'm going to go through the various key systems that we support. So ClearKey, LHG have developed a ClearKey media DRM and media crypto plugin. It's based off of the OpenSSL version that comes in the AOSP source code. But what we've done is modify it to use the Opti trusted application for the AES decryption. We've recently added support for secure buffers, so you can, if your platform defines a secure codec in Android and passes a secure buffer to the plugin, That's correctly handled by the TA, and the video is decrypted into it. We've also added some what we call SDP prototype code. So this is for platforms that maybe don't have the secure codecs integrated yet, but you want to test that you've got your ION secure unmapped heap set up correctly. So the prototype code will pass a secure buffer, but it relies on the actual memory firewall protection being turned off, so you can then remap the buffer and copy the data back into a non-secure buffer. But we have found it useful for testing, and the plugin creates a libdrm ClearKey opti shared object that's installed under the vendor partition. So some people often wonder, why do we bother with this ClearKey stuff? Why are you not just doing Widevine and Playready? Well, the main reason we use it is it allows us to have exactly the same data flow and architecture, but with a fully open source reference solution. So there's no proprietary code involved. Everything Opti is open source, the plugin's open source. You can download it, get a full end-to-end pipeline, and that's we believe that has value for our members. On the TA side, we've moved to a common branch for Linux and Android. We've added the support for the secure buffers, like I mentioned already. We've also added some zero-copy optimizations that remove 2 mem copies from the decrypt path, so that's on the non-secure side. We've recently been testing on the TI X15 boards, 32-bit SOC, and the 64-bit SOCs. We've moved to 64-bit TAs and 64-bit plugin, where previously we were using 32-bit. And we're mainly using the EXO Player media playback application. There's also a unit test available, which I've put the name there. That runs a series of lower level AES tests. So on the Playready side, again, we've developed a Playready crypto plugin and Playready DRM plugin for the Playready key system. That's the glue layer basically between Android APIs at the top of the plugin and the porting kit APIs. That plugin we then use in conjunction with the Playready for T interface TA, so that's again developed in LHG. We've recently added support for multiple key IDs, so that allows us to decrypt content where the audio and video are encrypted with different keys. And again, we have SDP prototype code, which I've already mentioned on the ClearKey works in the same way for allowing us to test SOCs that don't have the codec support. So this is a similar diagram, but just showing you where the various repositories for all this are. All of the Playready side is access restricted, so we can only give it to members that have signed the Playready license agreements. The plugin is here. Number 2 is mainly the porting kit provided by Microsoft, plus a bunch of patches that enable it to build correctly for ARM. And then 3 is the actual Playready for T TA that links with the porting kit library, but also includes a bunch of code from Linaro to make it work with Opti. So on the Playready side, we've recently updated to 3.3 porting kit release. We've added support for the secure buffer decryption, which was done by Alex, and that involved enabling what they call the handle back to memory APIs in the porting kit. We've also made the same mem copy optimization in the non-secure decrypt flow. There's a new TA command for secure mem copying, so this is for when you have the full SDP pipeline for unencrypted data, you need the TA to do the mem copy. And there's also been some improvements for better multi-DRM support, so when we have Widevine TA and Playready TA all coexisting, it doesn't allocate such big static buffers that mean we run out of memory. On the to-do, there's, as ever, a lot to do. We have more work to do on the secure clock APIs. We haven't implemented those yet. Also, enforcement of output protection levels. So the T should ensure HTTP and other protections are engaged and stop the decryption if they aren't. We don't yet have that implemented in the TA, and we're looking for a platform that will allow us to do a reference implementation of that. Currently on the cryptographic calls, we use the Microsoft C implementations. We'd like to move those over to Opt-T global platform APIs, and that would allow us, for SoCs that have accelerated those cryptographic functions in Opt-T, that would allow us to make use of that acceleration. We'd like to upgrade to the latest V4 porting kit from Microsoft. And we've had several chats with the Playready team about contributing some of our patches to makefiles and support for ARM back to them, because we tend to apply the same bunch of patches on each release to get it working in our environment at least. On the CI and test, Arthur is currently trying to get a Lava playback test working. We need to do more on unit testing. There's a pre-T test utility that we're in the process of getting working, but we need to wrap that in a Lava test as well, and more Garrett and Jenkins integration. So, last key system, Widevine. Google actually provides the Media DRM and Media Crypto plugins for Widevine, and they also provide the CDM layer. So you get a bit more for free in Widevine. The bit that is been originally done in SWG and LHG have been sort of maintaining is the OEM crypto layer. So this is the part which does all the key management in Widevine. And that's the API that you have to implement with Opt-T to have the decryption being done inside the T. So currently we're at the OEM crypto is quite a small API, strictly versioned. We implement V11 of that API. I think they're at V13 currently, so there's a task to upgrade to the latest OEM crypto release. And at a very nuts and bolts level, it is a case of replacing the OEM crypto shared object on your root file system with the new Opt-T enabled one, and then when you do a Widevine video, play a Widevine video, it will go off and be doing all the key management and decryption in the T. So this is a bit about what OEM crypto is doing. It provides a mechanism for establishing a signing key, a mechanism for establishing a key encryption key, and it provides a mechanism to give you a content key to decrypt the stream. Google also provide quite a lot of unit test code. So the unit test we've mainly been using is the OEM crypto test, which tests the OEM crypto library, which is the part that we've implemented with Opt-T. But there's also quite a few unit tests at the Media DRM and Media Crypto levels, and also at the APK level. We haven't been using those unit tests yet, but what we'd like to do is get those unit tests being run in Lava as well. And we're also using their ExoPlayer application for the video playback. So that's a brief look at the sort of output you get from OEM crypto when you run it. Updates for Widevine. Support for secure buffers has been added by Ken from ARM. We fixed the last remaining OEM crypto test failures, which Xiao's been looking at. We've migrated to 64-bit TAs for 64-bit SoCs. There's a new README to help new developers, and the secure decryption support is being used by ARM and also NXP on their platforms. The to-do list, so we'd like to upgrade to OEM Crypto 13, which is the latest release. That adds support for something Google called Provisioning 3. There's also more support for HTTP SRM messages, which is a way of denying certain devices that have compromised keys from outputting content over HDMI. I mentioned on the Playready, we need to enforce the HDCP protection within the T, so that's something we also need to do in Widevine, and we want to improve the automated testing with OEM crypto and the other unit tests. So SDP updates, this is all things we've really covered already, but all the TAs now support secure buffers. In Android platforms like IMX8 and Juno, which register secure codecs, you can get a secure media playback. On other platforms such as HKG, you have to enable the SDP prototype code. And one thing we've learned from this is that it's very hard to enable full SDP without very close collaboration with the member companies. So with NXP we've been working very closely, but it quite often requires a lot of chatting with the member engineers in that company and for them to get changes to various components. In terms of boards and SoCs, HKG, we support ClearKey, Playready and Widevine in Linux and Android, apart from Widevine where we don't have the Linux support yet. On NXP, we have the secure data path with Android. The Linux is in progress. And on the TI board, we have ClearKey and Playready working. And Poplar, the Android ClearKey and Playready is in progress. It's not quite there yet. And finally, if you or your member company are see a value in this, then we're always looking for people to help us get some of those to-do lists done. So I suggest getting in contact with us and letting your TSC rep know that you see a value in what's being done. Yeah, and that's it. So is there any questions from anyone? We finished a little bit early.
There's 20 minutes left.
I have a question.
Oh yeah.
There's a couple of mics.
Have you looked at headless use cases for audio only, or?
No.
No. Okay.
Anyone else? Okay. Well, I think we're done then.